which is threaded joint, in which we'll discuss power screws, temporary joints, and permanent joints, and design of threaded joints. Okay. So if we are looking at this slide, which is dimensions and tolerances.
सर इससे जो
जी
सर
जी
इससे पहले जो हमने नहीं पढ़ा है सर, हमने सिर्फ पेज ऑफ डिजाइन पढ़े थे।
यस सर, वहाँ से छोड़ा है हमने पेज ऑफ डिजाइन।
Actually, so we have standards and codes. If you um, if we go to standards, what are standards in mechanical engineering design? Well, rather in engineering there are certain standards. And what is a standard? A standard is basically um, a set of specifications for parts, materials, or processes. So if you are if you have a part or material or process and there is a set of specifications for that, so these are known as standards. And the the intent of these standards is to achieve uniformity, efficiency, and a specified quality. ठीक है जी? So जैसे अभी हमने कहा कि these are a set of specifications, कि what should be, if we are talking about a part, what should be the dimensions of that part, um, what should be the different aspects of that part. If we are talking about a material, there are standard materials to which we refer with standard names. And with those, in those materials, there are different constituents. They are processed in a certain way. And similarly, it is true for processes that they have some set of specifications which are standard, which are the same for all those processes if we name them standard. तो जैसे अभी हमने कहा कि यूनिफॉर्मिटी, efficiency and specified quality. So what does this mean? Is uniformity, if we are talking about a standard part, so that standard part will be uniform. Each of those parts will meet some criteria that will have the same dimensions and the same material, the same features. So you can basically go ahead and buy that part very readily. ठीक है? So because these parts are all the same. For example, there is a standard bearing, so you would just go to a hardware store and or to a supplier and order a standard bearing that will have the same dimension. So if you use a standard part, um, that part is available everywhere and it is uniform throughout. So it is not custom that every part is different from each other. It is not different from each other. It is rather the same part, and that would ensure efficiency and some specified quality for all these, if it is a part or a material or a process. ठीक है जी? Um, Again, it limits the magnitude, the multitude of variations. So when you use parts, there are no variations in that. It just, yes, it is. There is some variation, but that variation is just limited to the tolerance that you specify, or it is just limited to whatever um, uh, degree of variation you specify and which is acceptable. ठीक है जी? अम, इसी तरह if we look at codes, so codes are also um, a set of specifications. Rather, I would say it is a set of instructions how to carry out a certain analysis, certain design, and some manufacture. If you are manufacturing something or fabrication, or the construction of something. So these are basically a set of, I would rather say that it is a set of instructions, um, that how would you um, carry out analysis, जो हमने stages of design में discuss किया था कि how would you um, carry an analysis, design, manufacture, and construction of something. For example, the code for this, for the class, let's say if we are talking about a class, I'm just taking a very simple example just to make you understand. What is the code of class? The code of class is that you don't talk in a class when you are sitting in a class. You listen to the instructor. You would, if you have to ask a question, you would raise your hand and so on. So these are codes or this is a code of conduct. If you have heard, there is a code of conduct. So if you have to design something or analyze something or manufacture something or construct something, you would follow those codes. And again, it is to achieve a certain degree of safety. For example, if we are talking about an elevator, I would say that you have to, use these steps while designing an elevator. You have to keep the factor of safety from 8 to 12. That is also, a code. And so what does it do? Again, it is similar to this, that in code, it will achieve a specified degree of safety, efficiency, and performance or quality. For example, the code of when you are driving, you keep to the left in our country, right? So these are a set of instructions how to do things. Okay? If you have to enter into a construction zone, you should have a hard hat. If there are chemicals, you should have, steel toe boots. You should wear gloves and things like that. So these are codes, and you know, again, the standards and codes, they are meant to give you specific safety, efficiency, um, but they do not imply absolute safety. You have to build in safety into your design when you are performing, your design or analysis. Ji, Muhammad Umair, did you want to say something? Muhammad Umair, your hand is up. Did you want to say something?
सर
जी
सर तो आवाज घट रही है सर, थोड़ा सा अगर तेज बोलने सर आवाज कम आ रही है।
मेरे ख्याल में you have some problem with your connection because
नो सर, 2-3 स्टूडेंट ने मैसेज किए मुझे।
सर सर वो पहले सर पिछले मंडे जिस तरह आपकी आवाज आ रही थी सर उस तरह नहीं आ रही है सर, मतलब गूंज आ रही है उसी तरह
सर आवाज क्लियर है लेकिन थोड़ी दूर से
क्लियर नहीं है।
यस सर, आवाज थोड़ी क्लियर नहीं आ रही।
let's see what I can do because मेरे तो बिल्कुल मुंह के सामने
अभी
अब क्लियर है सर, अब जैसे
ठीक हो
मुंह
गया,
के
अभी
सामने
ठीक
रखे
हो
तो फिर सही है।
क्या करूं?
अब क्लियर आ रही है।
अच्छा, if I turn off the camera, how is it now? Is it good now?
फिर गर्मी होगी।
नहीं सर उसी तरह।
तो
उसी
माइक माइक तो मेरे बिल्कुल
अभी सही है आवाज
अभी
सर।
सही आ रही है, अभी सही आ
सही
रही
है सर।
जब माइक नजदीक हो सर फिर सही आती है, अभी ठीक आ रही है।
अच्छा अभी ठीक आ रही है।
जी सर।
यस सर अभी ठीक है
चले
सर।
ठीक,
Yes, sir.
ओके 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 okay. So so what we were saying about standards and codes now, I hope you got the idea of standards and codes. Now, there are various organizations that establish and publish these standards and codes for common and and or critical industries. Um, for example, these organizations are uh, well, we have just picked the organizations that are of your interest, which are um,
American.
for example, हम कहते हैं कि अमेरिकन एल्यूमिनियम जो एल्यूमिनियम एसोसिएशन है which is AA. You have American Iron and Steel Institute. You have British Standard Institute. There is ASHRAE. We have a local chapter of ASHRAE. You have ASME, which is American Society of Mechanical Engineers, American Welding Society, International Standard Organization, um, and Society of Automotive Engineers, which is SAE. So you would have seen, देखिए, have you seen मोबाइल जो होते हैं गाड़ी के, if you look at that, तो उस पे लिखा हुआ होता है SAE with some number. For example, SAE 30, ठीक है जी, इसी तरह you would have seen that is a standard, ठीक है जी. So that has some specific viscosity, that has some specific um, properties that comes with this standard. Similarly, if you look at as we have American Welding Society, तो आपने अगर welding rods इस्तेमाल किए हैं, तो that will have certain properties. There is a specific number for that. So there is a specific standard yield properties उसकी होंगी, ultimate properties होंगी जब आप वो welding rod इस्तेमाल करते हैं, and so on. ठीक है जी. So these are standards, and again, these standards would bring interchangeability. They would bring uniformity and safety and efficiency into your design. ठीक है जी. Now, if we go further, so let's talk about economics. अगर हम economics की बात करें, तो how do we bring down economics when you are trying to
एक्सक्यूज मी सर.
जी जी
सर ये कोर्स जो है ना, ये हमें मटेरियल के बारे में बताते हैं कि ये कौन सा मटेरियल है, ये बेरिंग जो बना है किस मटेरियल से.
जी, सिर्फ मटेरियल नहीं बताता बल्कि उसके स्पेसिफिकेशंस भी बताता है. फॉर एग्जांपल, अगर हम बेयरिंग की बात करते हैं, तो बेयरिंग में वो आपको इंटरनल डाया भी बताएगा कि इसका ये डायामीटर है, उसका ये आउटर डायामीटर है, और जो स्टैंडर्ड मटेरियल होता है उसके बारे में भी आपको बताएगा कि ये इस मटेरियल से बना हुआ है. सो फॉर एग्जांपल, मैं आपको एक बहुत रॉ एग्जांपल देता हूँ. इवन हमारे जो जो बेड्स हैं, वो उसकी क्या स्पेसिफिकेशंस होती हैं. जो सिंगल बेड है जिस पे हम सोते हैं, वो एक खास साइज का होता है ना. ऐसा तो नहीं है कि आप कहीं जाते हैं तो इट कैन बी बिग, इट कैन बी स्मॉल, लेकिन स्टैंडर्ड साइज यही है कि वो 3 by 5.5 या 3 by 6 फीट होगा, या 3.5 by 6.5 होगा. And that's the standard size. So if you go to multi-foam or जिस पे भी जाएं आप उसको कहें give me a foam for my single bed, so they'll just ask you, okay, is it 3.5 by 6 or something, which is the standard size. So वहाँ से if you have that standard size, you just go ahead and pick that up. लेकिन अगर आपने कोई बहुत ही कस्टमाइज साइज बनाया हुआ है, तो देन यू हैव टू वेट एंड दे विल मेक अ कस्टम मैट्रेस और अ कस्टम फोम फॉर यू. जी, डिड आई आंसर योर क्वेश्चन?
यस सर, थैंक
यू. नादिरुल्लाह, डिड यू वांट टू से समथिंग?
नो सर, ना सर, गो फॉरवर्ड.
आपका हाथ नीचे कर देता हूँ, ठीक है जी.
ठीक.
अच्छा, तो नाउ लेट्स से अगर हम बात करते हैं कॉस्ट की, हाउ डू वी ब्रिंग आवर कॉस्ट डाउन व्हेन वी आर डीलिंग विद व्हेन वी आर टॉकिंग अबाउट डिजाइन. देखिए कॉस्ट के बारे में रिमेंबर अ फ्यू थिंग्स जिसके जरिए आप अपने डिजाइन का जो कॉस्ट है वो आप you can bring it down. For example, the first thing is I would list that over here, um, and that is if I want to uh, you know bring my cost down. So what would I do is first of all I would use standard sizes. ठीक है जी? Now, why would I use standard size? Because standard sizes जो है, they are made in bulk, right? So the more parts that are produced in huge quantities, their cost is going to go down. Now, if I use standard sizes in my design, there is another advantage to that, and that advantage is that I do not have to go through machining. So it eliminates my machining. ठीक है जी? And it eliminates my labor over there. So I will use standard sizes if my design allows you, if it is not going to hurt the functionality of my design, I'll go for standard sizes. ठीक है जी? Now I should also go for using larger tolerances. Okay. Larger tolerances would mean if my design allow me, I will use larger tolerances. क्योंकि larger tolerances में there is a benefit. एक तो ये है कि what is tolerance? Do you know what tolerance is? देखें, अगर tolerance है हमारे पास, for example, I have a diameter of a shaft that is 2 inches, ठीक है जी? So with these 2 inches, I say that it doesn't matter if my my design of this, yeah, when I make this shaft, when I make this diameter, it is okay if the shaft is plus minus 0.001 inches. ठीक है जी? What I mean is if it is 2.001 inches or 2.0 0009 inches, it is still fine. Or if it is on the other side, if it is 1.999, that is still fine. So there is a range, or there is a limit that I define, that if it is if it is within this plus minus, I will still keep this shaft. ठीक है जी? I will not keep this shaft if it is 2.02 inches, because that is very large. Probably my design does not function with that. So, or if it is 1.8 inches, when I produce it, it is not going to work for me. Therefore, now the thing is, if I use large tolerances, there is acceptability for a wide range of these shafts. Plus, if I use larger tolerances, I do not have to do inspection all the time. नहीं, अगर मैं tolerances को बहुत tight रखता हूँ, तो then I will look for the part everywhere that it goes, everywhere that it is machined. I look for the dimensions of this shaft, that they are not exceeding a certain limit. Otherwise, I'll reject them. So एक तो rejection will be more. ठीक है जी? If I keep tighter tolerances, if I keep tighter tolerances, my my machines will be very accurate machines. I'll have to buy very expensive machines. My labor will be expensive. I have to set up many inspection points to inspect all the parts. ठीक है जी? कि सारे parts जो है उनको मैं inspect करूं and देखूं कि वो एक खास limit को तो cross नहीं कर रहे. तो जितना मैं tolerances को tight रखूंगा, उतना क्या होगा कि मेरे जो cost है वो बढ़ती जाएगी. Therefore, if I can work with larger tolerances in a design, I would go for larger tolerances. ठीक है जी. For example, यहाँ पे अगर हम देखें तो ये relationship है आपके larger tolerances का और tighter tolerances का. If I keep the tolerances large, for example, यहाँ पे अगर आप देखें तो this is the tolerance. ठीक है जी. This is the tolerance. ठीक है जी. ये और यहाँ पे जो है this is the cost. ठीक है जी. तो what happens, देखें, if I keep the tolerance up to a certain value, for example 0.030 plus minus, and I keep on decreasing, keeping the tolerance is more tighter. For example, यहाँ पे 0.01 बन गया है. Over here it is 0.001. देखिए, इससे मैं आगे बढ़ता हूँ ना, तो what happens, my cost goes really up, and that is kind of scary कि इतना steep बन जाता है in percent. देखिए, with smaller tolerances, with tolerances that are on the loose side, this is the curve that I have. लेकिन अगर मैं tolerances को बहुत tight करता हूँ, तो then my curve goes up like this, which is very much, it goes up to, यहाँ पे कितना है, 400% तक. And again, as I said, you have to have many inspection points. You have to have, many there will be many parts that will be rejected, and your machines will be of very precise, and they should be very accurate. इसी तरह आपकी जो प्रोडक्शन है वो भी लो होगी. ठीक है जी, because of the tighter tolerance. So this is one way that we can keep our cost low. ठीक है जी. Now, if I go further, there is another method. जैसे if we want to see which method is the best method. देखिए, in design you might have different designs. You might have 2 or 3 designs, and you want to choose which design to go with. ठीक है जी. And for that you can do an analysis of your cost. For example, एक analysis हम करते हैं जिसको हम break even point कहते हैं. ठीक है जी. So what does this break even point do is, let's say for example we have to there are 2 possible ways to manufacture something. Let's take the example of screws. ठीक है जी. So let's say we have to manufacture screws. Here we have to fabricate screws, and there are 2 ways that we can use. One is an automatic screw machine that we can use, and then we can use a manual process, which is a hand screw machine. तो इस hand screw machine में हम क्या करेंगे, और automatic में हम क्या करेंगे कि first of all let's see what are the costs that are associated with that. For example, automatic machine में हम जब screws बनाते हैं तो it makes 25 parts per hour. And then there is a setup time, which is 3 hours setup time. So in these 3 hours, the machine doesn't do anything. You have to set it up. You have to make the machine ready. ठीक है जी. Let's say 20 rupees per hour आप कर दें या dollar per hour कर दें. So that is the labor cost. ठीक है जी. Now, अगर हम इस चीज को यहाँ पे अगर हम इस चीज को प्रोड्यूस करें, तो देखिए सबसे पहले वी हैव कॉस्ट. ठीक है जी. ऑन दिस साइड अगर आप देखें तो ये हमारा कॉस्ट है, और इस साइड पे वी हैव द प्रोडक्शन. ठीक है जी. तो एज वी सेड, सबसे पहले हम ये ऑटोमेटिक प्रोसेस को लेते हैं. ठीक है जी. तो ऑटोमेटिक प्रोसेस में क्या है कि वी मेक 25 पार्ट्स पर आवर, लेकिन फर्स्ट 3 आवर्स में कुछ भी नहीं बनता, ठीक है जी। तो लेकिन लेबर कॉस्ट तो होगा आपके फर्स्ट 3 आवर्स में, तो आपकी कॉस्ट क्या आएगी, जीरो प्रोडक्शन होगी 20, 40 एंड 60। तो यहाँ से आप शुरू करेंगे व्हेन वी आर यूजिंग ऑटोमेट